Hi, everybody. Welcome back. My name is Nikki, and we have Sam here as well. We are
Hello.
just here to go over webinar episode 3, which is very exciting. It'll be our reasoning models and LLMs, which Sam has kindly put together for us, and I will let him take over from here.
All right. Thank you, Nikki. This is our recording webinar on reasoning models and learning large language models. Let's dive right into it. So first off, what is a large language model? A large language model is an AI system trained on vast amounts of text from books, websites, right, any other sources. And it learns patterns in language to generate text responses. And I've covered this in one of our past episodes if you want to look at that. It works by predicting what word should come next based on the context. So examples are early versions of ChatGPT, Claude, Google Gemini. If you've been using Google in the past couple months, their AI is based off of Reddit, I believe. So that's an example of another source that large language model can pull from. Now, what is a reasoning model? Reasoning model is a more advanced type of large language model with enhanced abilities to think through problems. And usually they call this the train of thought. That has a dedicated thinking mode. This is what the train of thought is before it produces answers. It'll usually walk you through its thinking steps and its process. And it does take a little bit of time to consider all the angles of a problem. And these are the newest models that are reasoning models. Claude 3.77 and GPT version 01 and onward, I believe, are used in models. And traditional LLMs, how they work, just to recap, they respond quickly based on patterns used during training. The training is done on the data that they collect. And then it generates text word by word in a continuous stream, kind of like having a conversation with someone who's speaking off the cuff. They don't know exactly the full context, but it knows the next word. So things very immediate, provides very immediate responses. Now, reasoning models, how they work is they take time to think before answering. Much like a human, this is one of the steps they've been doing to get closer to how humans think and our train of thought. And they process information in multiple steps. It acts like someone who pauses to consider a problem from different angles. So instead of, for example, me saying, what day is it? Oh, immediately Wednesday. Reasoning models will sit and think, like, okay, let me go through all the data I have. What day is it? And then we'll answer. So thinking before speaking is kind of the gist of what a reasoning model does. It might internally debate with itself on the best approach before responding. This is actually really cool to see in ChatGPT because it'll list it all out. And that's boilerplate how reasoning models work. Now, there's they don't entirely wipe out large language models traditionally. Traditional LLMs are still very fast. They provide immediate responses. They're very efficient. They're with straightforward questions. And very versatile. They have a wide range of topics and they cost less to operate per token, especially with reasoning models we'll get into. They are a little bit more expensive to run. Cons of traditional large language models. Just surface level reasoning. Again, they might miss deeper insights or why something might work. They might just know, hey, this works. It can be very confident in errors and hallucinations. And you really have to watch out for that when working with traditional LLMs, stating incorrect information. And it does have limited problem solving. They tend to struggle with multi-step reasoning and things like coding problems or, multiple step problems like that with a lot of thinking before getting an answer. Things like complex math problems as well. And they can be very consistent and they contradict themselves in complex scenarios. If you use a lot of large language models in the past, I'm sure you've run into this at some time where contradicts itself and doesn't quite know what to do. It just knows basically what it's saying. Now, onto reasoning models and the pros. They do provide a deeper analysis. So they consider multiple perspectives, and they are better at problem solving more complex problems. Multi-step problems, again, things like coding, higher level math problems, and they tend to have a higher accuracy, tend to make fewer reasoning errors due to that train of thought, that thought process that we talked about earlier. And self-correction, it can catch and fix logical mistakes because it goes through the logical thinking process that similar to what we would go through and thinking through a problem. Now, the cons of reasoning models, they have slower responses. It takes more time to generate answers, and they are more expensive to run. And definitely overkill for simple tasks. We'll get into a little bit later when you would want to use a large language model traditionally versus a reasoning model. And reasoning models are still imperfect. They still can hallucinate, despite their additional reasoning. They're still susceptible to making those kinds of mistakes. Let's talk about use cases. For traditional learning language models, content creation, writing emails, blog posts, marketing copies, information retrieval, getting quick facts, casual conversations, just chatting, very good at that, and language translation, again, just converting text between languages, very easy, not a lot of thinking. It has the answer, it knows based on context what's going to come next. These are, I would call these somewhat trivial tasks. Instead of asking someone, hey, can you think through this problem? It would be similar to saying, hey, go get this answer for me. It's a known answer. You don't have to think about the answer. You just have to get it. That's the sort of use case we're looking for when using traditional LLMs. Now, when to use reasoning models, again, complex problem solving, mathematical, logical puzzles, something you have to think through before answering. But the answer is not immediately obvious. Critical analysis, evaluating arguments or research papers. Again, that's attributed to the thinking process, the train of thought that it goes through before it makes any decisions or gives final answers. Weighs multiple factors and options before giving you that answer. And code debugging, finding errors in programming logic. This is something I personally use, I'm a big fan of, because large language models previously could get pretty close, but the logic just simply wasn't there and it didn't make sense and it wouldn't work. By choosing the right tool, a couple of questions that you should ask yourself. Number one, how complex is my question or task? If it's more complicated, more likely to use a reasoning model. And if it's something trivial, like, hey, I need a quick email to send out to my boss or something like that, that's more suited to traditional LLM. And number two, do I need a quick answer or a deeply considered one? This is, again, something to consider. Quick answer, something like emails, and the trivial tasks we were kind of talking about earlier. That's something for a traditional LLM. And for any sort of consideration or problem solving, logical processes, go to a reasoning model. And is accuracy critically important for the situation? If it is, again, reasoning models are your best bet. Although this comes with an important anecdote, it is always important to have a human review the information to determine if it is accurate. Because again, reasoning models can still make mistakes. They are remarkably human in that way. And what's my time and resource budget? As great as reasoning models are, they do come at a cost, quite literally. They're more expensive and they take more time to generate, depending on what you're doing. If you're sending out a bunch of emails real quick, a large learning model, traditional LLM, that would be more useful. Something like ChatGPT 4.0, earlier versions of Claude. Those are going to be your best bet for tests like that. And some key takeaways to talk about here. Traditional LLMs very fast, efficient, good for everyday tasks. Reasoning models, deeper thinking, better for complex problems. They both have their place. It does take a little bit of time in using both of them to kind of realize what they're useful for. But this technology is evolving extremely rapidly. It's important to keep up with uh, learning language models and the reasoning models. They are starting to get cheaper, but definitely something to think about when determining what kind of model you want to use. And that's all I have for you today. Are there any questions?
I thought that was really well thought out and it answered most of my basic questions. I think the
Hmm.
only thing I'm curious about, whether in ChatGPT, Claude, whatever you want to use as an example, when I go to the website, it just seems to pick a model for me. How would I be able to navigate and choose whether I want to do an LLM or reasoning?
That's a good question. Let me log in and then I can give you an example of how to do that with ChatGPT.
Yeah, because I guess I've never thought of even trying and switching between the two. So
Yeah. Let's see. Can you see this?
I cannot. You might still be in presenting mode.
Not all right. In 1 second. All right. So here we are in ChatGPT.
I
Um,
still can't see your screen. I'm sorry.
oh, really? Come on.
There you go.
Okay. So if you log into ChatGPT, this is what it'll bring you
Mhm.
to. Up here, you'll see you can choose your model, and
Uh,
it does have a little explanation of great for most questions, schedule tasks. They've also been adding a lot of user specific, or I guess task specific features with ChatGPT. But these are all large learning models, large language models. Um, and then we get to O1, O3, O3 mini. These are the advanced reasoning, and these have train of thought. Um, and you can see they have some legacy ones, but for honest, these shouldn't really be used. These are usually far superior for most questions.
cool. So
Um,
now I can kind of just mess around and see what is best for depending on the task. I never knew that before.
yeah. Again, just those couple questions, those key takeaways. Um, what are you asking it to do? Um, that's important to think through before committing to the prompt. And again, to go back to I believe the first webinar we did, you want to be specific with your context and your everything else. Excuse me. Um, Everything else we talked about in the last one, you can go find that on YouTube or wherever it may be. Yeah,
Cool. I think that is all my questions I have. We encourage anybody watching to leave them in the comments, and we'd be more than happy to reply. Thank you so
absolutely.
much, Sam, for going over all this really useful information that will be very helpful to beginning nonprofits getting started in the tech world. This was episode 3 of our Wiki Charities webinar. We look forward to seeing you next time.
See you next time. Bye.